So I found this pretty interesting chain rule problem, and I thought that I would just go over it to sort of explain how you would approach this type of problem. First things first, you want to go ahead and break this down into its compositional parts. We'll have an outer function, which in our case is going to be equal to x to the negative 4/5 power, and then we'll have an inner function, which is going to be everything that's inside of the parentheses. So that is going to leave us with 8x minus x to the 6th power over x cubed. Okay, so let's go ahead and let's go on with it. So we have when we're taking the derivative of this function, as per the chain rule, first we have to take the derivative of the outside, which is going to leave us with negative 4/5 times our x, which in this case is everything on the inside here, 8x minus x to the 6th power, all over x cubed, and then we subtract 1 from this, which is minus 5/5, or negative 9/5. And now that we have done the outside function, we'll go ahead and take the derivative of the inside function. Now, I personally don't like using the quotient rule. I don't know anyone who does, but what I like to do is I like to turn these types of problems into product rule problems, and we can do that simply by rearranging the function such that we have x to the negative 3rd power instead of x cubed in the denominator. And this is going to get fairly complicated, so you'll just have to follow along. But to use the product rule in this case, we'll go ahead and we'll take the derivative of the first function here, which is going to leave us with 8 minus 6x to the 5th power times x to the negative 3rd plus, and then we're going to leave the first function as it is and take the derivative of this function over here, which is going to be negative 3x to the negative 4th power. And now that we've, looks like you can't see it, now that we've pretty much done all of the calculus that we're going to be doing, what follows is just a bunch of algebra, and it's really easy to make mistakes at this point in solving the problem, so we'll definitely make sure to take care not to miss out on anything. But we'll go ahead and begin. So we'll start with the left side. We have negative 4/5 times this to a negative power. Or in other words, what we can do is we can actually flip the numerator and denominator and make this a positive exponent. In other words, we have negative 4/5 times x cubed over 8x minus x to the 6th power up to the positive 9/5 power. And for now, that's all we'll do to this side, and then we can go ahead and begin to simplify this. What we're left with is 8 minus 6x to the 5th power all over x cubed plus 8x minus x to the 6th power. And because this is a negative exponent, we'll go ahead and we'll put this in the denominator right away. So this becomes negative 1 over 3 times x to the, I apologize. This would become negative 3 times 1x to the 4th power. And again, it gets pretty complicated at this point, so you'll just have to bear with me. And again, these terms are all being multiplied with one another. We'll continue our simplification. Here, we're going to have, when we apply the 9/5 power, basically what that's saying is everything on the inside is going to be to the 9th power, and then we're taking the 5th root of it. So this becomes negative 4/5 times the 5th root of all of this up to the 9th power, so x cubed over 8x minus x to the 6th up to the 9th power. Make sure to close that. And here we still have the 8 minus 6x to the 5th power all over x cubed. And then we can go ahead and simplify this. I forgot to mention that this should be in its own parentheses being multiplied by the simplification of this part. What we'll have now is minus, and then 8x minus 6x times 3. Now, I moved this minus sign to the front just because it's going to help me keep track of the signs, but I just didn't want you to, I wanted to explain that because I didn't want you to think that I just pulled the negative sign out of nowhere. And then all of this is, of course, over x to the 4th power. We can actually combine these functions. We'd have to multiply the numerator and denominator of this function by x, which we can actually do. It's not a problem, so we'll go ahead and do that right now, actually. We'll multiply both by x, and this becomes negative 4/5 times the 5th root of x cubed over 8x minus x to the 6th power, all up to the 9th power, times 8x minus 6x up to the 6th power, all over x to the 4th. And because I want to save time, I'm going to go ahead and just distribute this 3 right away, and I'm going to distribute the negative sign as well at the same time. So what we have is 3 times 8x is equal to 24x, and then times the negative 1 makes it negative 24x, and then negative 6x times 3 is negative 3 times x to the 6th, and then times another negative number makes it positive, so this would be plus 3x to the 6th power. And I already see terms that we can combine, so we're going to make this equal to negative 16x, and this becomes negative 3x to the 6th power. And finally, I'm just going to, well, we'll do that at the very end. So we'll go ahead and simplify this, and we have negative 4/5 times the 5th root of x cubed all over this up to the 9th power times negative 3x to the 6th minus 16x all over x to the 4th. Great. So now what we have to do is we have to we'll try to combine these. It's definitely not an easy thing, but what I'm going to do is I'm going to take this negative 4/5 and I'm going to combine that with this fraction over here, because it doesn't look like we can do much with this. I mean, I'm sure there is, but not much that I want to do. So what I'm going to do instead is I'm going to combine this fraction with this fraction that doesn't have a radical. And when we do that, it's basically the same thing as saying take the negative 4 and multiply that by the numerator, and then take the 5 and multiply that by the denominator, or x to the 4th over here. And we'll keep this in the front, so we have the 5th root of x cubed over 8x minus x to the 6th power all up to the 9th power, and this is going to be multiplied by this function times 4, so times negative 4, excuse me. So negative 4 times negative 3x to the 6th is equal to positive 12x to the 6th power, and then negative 4 times negative 16x is equal to positive 64x, I believe, and this is all over 5 times x to the 4th power, or 5x to the 4th power. And we've done it. We've finally solved this problem. Wow. Okay, so if you have any questions, feel free to leave them in the comment section. I really appreciate it, and I hope this was helpful.